Greetings, programs. Welcome to Stegosaurus Studios. I'm Mike. We're out in the shop. Dummies hasn't made any progress since the last episode. He's still out here. So still am in the design phase. It's taking forever. I have a few little things to show you, and then we'll talk about some design screw-ups. So come back after the whirly dinosaur and we'll talk things through. All right, okay. At the end of it, well, in the last episode, we talked about Ackerman's steering geometry. I showed the rear steering system and the rear shock. Well, I think we had talked 2 episodes ago about the shocks, but so at that time there wasn't any design on the front. I've done a lot of design work on the front now, and that is what I want to talk about. So if you recall, in the back I was incorporating mountain bike shocks. Oh, it's way over there. I couldn't really come up with a way to incorporate those in the front. And so I actually was hunting. I spent a lot of time on McMaster-Carr's website. I came across this. This is an air spring. And it's a mini air spring. And actually this is going to probably, I think, work pretty good. As far as lifting force, it's right in the range of where we need it to be. So I'll probably just pump like, so it has an air fitting that's connected to it right now. I'll put like 10 to 20 pounds of air pressure in it, and then it'll sit in the frame between the wheel and the and then it'll actually, it has a little bit of a compression even just when it's uninflated. So so I had found these, and I had started the front design. Actually, was quite a ways into the front design, front wheel design, and then I saw this one. This is another one, different style, but it's still a air spring, and it, you know, it compresses, right? So so here's the thing: those mountain bike shocks, you know, I took most of the air out of one and tried to compress it, and I put all my weight on it, and I couldn't get it to compress at all. So my concern was that it was going to be too stiff, because, you know, this guy, he's made of plastic, isn't weigh that much, you know, and the rest of the body panels are all going to be 3D printed plastic as well. So the frame is going to be the heavy part, the frame and the batteries and electronics, and anyway, a spring that's made to support a human, which is what a mountain bike shock is, might be a little too heavy. This one in particular has numbers that are right in kind of the range, like the 40 to 60 pounds, so 2 of them. So anyway, I was thinking I would switch over, and then I was driving in my car, and my car has air shocks. And it can actually, it has something very similar to this, but it has the feature where it can raise and lower the ride height. And I'm driving my vehicle, and I realized, well, that's kind of well, it's not kind of, that is what we want to do on the speeder bike, right? We want to bank in the turn. We want to raise the ride height on one wheel and make it, you know, make it bank in the turns. So I started thinking, well, could we use this thing, this air spring, not only for shock absorbing, but also to adjust the ride height? So, and then as far as air to it, you know, you'd have to put in a regulator and a couple of control, 2 or 3-way control valves to let air in and let air out, to raise it and lower it. And then the air, you could probably just use, I'm thinking we could use a small tank that is used for paintball. So those small tanks, you can get some that go up to 4,000 psi. 4,000 psi in a tank like that, probably run these things, which are going to be running at like 30, 20 pounds, probably do quite a few transitions. And then you could just have 2 of those bottles or whatever, and you could swap them out. So kind of excited that maybe that's going to work. Totally untested. So actually, and I need to make some changes to the design in order to incorporate them, but air springs. So that's kind of where we're heading. Now, I think I'd mentioned I'd done quite a bit of design on the front end. In fact, I was calling it kind of finished. And then, not last night, but 2 nights ago, woke up at about 3 in the morning, kind of couldn't sleep, and did a little design review in my head and realized that it was screwed up. It was upside down. the front fitting, or the front steering suspension system. And then, as I was making some other changes, I encountered another mess up, this one on the rearing. The rearing, yeah, that's a real word, on the rear steering suspension system. So I actually recorded a video, which we'll get to here in just a second, that was on the computer. I recorded it initially to send it to the local R2 Builders group, asking kind of for help. But so we can watch that, and then come back and probably put the caps on this episode after that. So come right back after watching the video. Okay, I hope this is recording. Hey guys, so it's been a very frustrating day with CAD and design. So this is the front wheel assembly, steering and suspension for the front wheel on the speeder bike. So let me explain what's going on here. So the wheel basically rides up and down on an assembly. So these vertical members right here, they slide up and down in these linear bearings. So there's 4 linear bearings and 4 uprights. So 1, 2, 1 over there, 3 and 4. So this entire assembly slides up and down in these linear bearings. So the wheel, as it hits a bump, the thing moves up. And then these cylinder things here are air springs. They act as shock absorbers. So I mentioned on in the random channel on Slack. So the frame, the main frame, is connected to the air spring at the bottom, and the wheel frame is connected to the air spring at the top. And what that means is the weight of the frame, instead of compressing the spring, is actually pulling the spring. The frame is, like I said, connected to the bottom, so the weight of the frame is pulling down on the air spring, and that's upside down. So I need to figure out a way to flip this around so that the weight of the frame is compressing the air spring and not pulling on it. So that was what I realized at 3 o'clock in the morning. And then, so I was making some changes that Malcolm and I met for coffee yesterday. And so I was making some changes, and then after I made the changes, I turned all the joints on, and then I realized, or I encountered this problem as I started. Well, so what I'm going to do here, so all the joints are turned on. So I'm going to grab this and just push it up, which will compress this, which will be an air spring here as well. But watch what happens to the wheel assembly as I do this. So it is turning the wheel assembly. And it took me a little bit to figure out what's going on here. So we've got this wheel clamped into this, these brackets here. This is the steering arm, and it comes straight out, and then there's a ball joint and then a tie rod that goes into an inline ball joint. And to go back to, I hate it when it does that. So to go back to this straight on view, this ball joint, or this end of the steering arm actually, so when when the wheel hits a bump and it's trying to move upward, the wheel is trying to move upward, this end of the steering arm describes an arc, right? It arcs this way. But it doesn't arc around this ball joint. The center of that arc is actually down here. It is where these pivot nubs, so these are pivot locations here for that arm. And what that means is, as this arcs up, it's trying to essentially shorten this tie rod. And the way I have it constructed does not allow for that to happen. And so it displaces the wheel. So if you wanted to drive it this way, you would have to understand what the angle is on the kingpin arm, and then on the fly adjust the rack position as you hit a bump and the angle, the steering or the kingpin arm changed. You would have to adjust the rack position on the steering. And if I thought the math on just figuring out the steering angle was hard, that's like an order of magnitude harder. So I'm not going to do that. So I need to figure out the changes to this to take into account as the wheel moves up and down because of road, poor quality bumps. This takes that into account somehow. I have a lot that I need to change now. And oh, and by the way, I have no idea whether this this front wheel thing is going to work at all. I don't know. I'm not a mechanical engineer, but I'm working on it. So that's that. All right, you're back. I'm back. I'm still here. Dummy's still here. So developments since that video that you just watched. Malcolm is pretty concerned. So the front wheel system has those 4 sliders that it rides up and down on. And rightfully so, he's concerned about it binding. I was a little concerned as well. So he actually sketched up a design for a different style, completely different. So it's going to mean ditching that whole thing and the whole front thing and kind of starting over. But probably work better, more robust. And so I got, it's still incorporating this, which is good. But it'll be a little less complicated. So I have to rework that. And then the rear, I think I know the solution. I need to make changes in the model and then test it and see if I can eliminate the issue with the steering arm. So anyway, that's the status. Still doing a lot of fusion, or confusion as I like to call it. And but this is why we design, and actually this is why we do things in 3D Fusion. I think it's probably cheaper in the long run to spend a lot of time testing things, and I really like the ability in Fusion to create joints and then move things, and because with that, that's how I uncovered that, it was torquing the wheel when raising. So anyway, that's the status, and this is probably, I don't know how much this is going to be, but this is probably going to be the end of the episode. So hopefully the next episode, maybe, knock on wood, I'll have some more parts in hand and actually be building some stuff. So thanks for tuning in. Talk to you next time. Bye.